first speaker is Jeff Casimir. He runs Jumpstart Lab in Washington, D.C. They do a lot of Ruby on Rails training. He's also the author of the Draper Gem, and which was just released recently. And he's going to talk today about the problem is your Ruby, which I bet you didn't know.
So, as Josh said, thanks for getting up early. No thanks to Square for getting people hungover and so forth. But thank you for getting up early. Now, this actually, it feels early. I know San Francisco hours, it is early. When I spoke at Lone Star RubyConf, I went on at 8:45. So it could be worse for me and for you. What we have today is a talk titled "The Problem Is Your Ruby." As Josh said, I teach Ruby and Rails classes, I travel around, work with a lot of developers. One of the most consistent challenges I see for Ruby and Rails developers is overestimating their expertise. People often come to me and they say, yeah, I've been doing Rails for like 3 months now, I'm ready for an advanced class. And I say like, well, honestly, the salesperson is like, yes, we can make that happen. And I'm thinking to myself, okay, we'll do like a medium class, a lower intermediate class, we'll feel out what your needs are and kind of meet you there. The reality is, expertise is a little more foggy than we think about. As programmers, the art of programming, the job that most of us embark upon, is about translating. It's about translating the challenges and problems of the real world into language that these chips and binary can understand, right? That the hardware can speak. And it's hard, and we tend to write crappy software. And I think that misunderstanding of our expertise is part of the reason. Are we bad at Rails, or Ruby? Do we build bad applications because we're bad at the technologies? There's been discussion lately, is Rails getting harder? I don't think so. In 2005, the API was much smaller. It was easier to kind of grasp more or less the whole thing. But the problem, I think, is that in learning these technologies, people kind of focus on the wrong thing. There's actually no point in being a Rails expert. I hope that does offend some of you if you consider yourself a Rails expert. I think it's the least valuable part of the equation. Instead, we really want to be expert on building applications. Because Rails is not a language. Okay? It's just a connector between ideas. It's the least interesting component of this application. Great developers obviously need Ruby. You'd be surprised how many people I work with say, oh, that was the first time I could tell the difference between Ruby and Rails. Woo. Expertise in components like these are more important than what you know about Rails. A lot of what Rails does is beautify the last 10% of your application. The conditional statement that turns into a one single method call, those kinds of little things out of active support. All these components, being expert in any of them, I would argue I would rather have you than a person who thinks they're expert in Rails. So, great developers focus on these, what I would consider real skills. If you want to up your game as a developer, you need to focus on object-oriented design. This is probably the biggest challenge that I think people have, and I can understand why. I could stand here and I could tell you to read patterns of enterprise application architecture, but I didn't read it. I can tell you to read design patterns. I didn't read that either. Back small talk, be true Ruby hipster. Didn't read it. So I started thinking about how did I learn about object-oriented design? How did I understand how to break down these complex systems? The truth is that I'm much better at buying books than I am at reading them. My Kindle is like full, my bookshelf. I end up just giving them away. Like I take it to the user group, I'm like, I'm never gonna open this. Like you guys, one of you will do it, so take it. So I wanted to talk to you a little bit about how I got here. Now this is very, as a Ruby programmer, I know I'm supposed to have studied like art or music in college, or like majored in piano or whatever. And I did a degree in computer systems engineering. It was like computer science, but it's a little bit harder. We had to do a lot of physics, we had to do a lot of math and all that. The things we didn't do were object-oriented design, software testing, databases. I had never used a database. When I graduated college, I never touched a database. And I was interested in web applications. So I contacted a friend of mine and said, how do I do this database thing? And he's like, oh, you're gonna get this book. And when I look back at my understanding of breaking down complex problems, this is probably the most eye-opening book I ever read, or read half of it. Instead of seeing data in a single mass, that book and the whole premise of SQL and database design helps you see how things are broken up, where the lines can be drawn, how they can be compartmentalized, to see the relationships, to see the plurality. And really, the whole challenge of programming is taking ideas from this to that. When a customer comes to you, they never say, oh, I need these 8 components. They say, I want this thing. It's going to be awesome. Make it. Right? And if you can figure out how to draw those lines, then you will be successful. So database design. I saw the 15-minute blog video. This was back before YouTube. I know there's like pre-YouTube days. Right? I don't even know how we watched the video before that. But I watched it. I was working on a JSP project at the time for the EFF here in San Francisco. And it was at lunch. I watched the video, deleted my project. I was like, okay, we'll start over here. This is so much better than what I'm doing. So I have to use this Ruby thing. How little of that do I need to do what I want to do? And that's, whether you want to admit it or not, I bet 4 out of 5 of us probably had a similar thought at some time. I want to build these web applications. How little Ruby do I need? I just wanted to connect my database to the web. I wanted to take this understanding of breaking down problems in the database and connect it to the web. I needed Ruby to do that. Because of that premise, because of beginning at the database level, the data drove my design. And projects that I see that are struggling, people that are struggling with tough problems, it almost always turns out that the data is driving their design, not the interface, not the front end, not how things should work. Many apps get stuck here with data driving the design of the Ruby. So a few years later, we started talking about REST, and this is another book that I read like half of. But I was so excited. It was because I started reading it. I was so excited about what I was learning that I couldn't wait to get started. I was like, I'll come back to this. I didn't come back to it. The idea in there that really struck me was search as a resource. Because implementing search before, I'd always used, like some get parameters and just kind of thrown in the URL and queried my thing. And having search as an object, I was like, there's no searches table. How can there be search objects? Oh, shit. Why didn't I think about that before? And that was like the critical understanding that I think a lot of people continue to miss. When you have objects, they don't need to be tied to persistent data. Objects aren't tables. Data existing in your application is different than data persisting. Search has data. It needs to have some query, some string for its request lifecycle, and then it can go. It doesn't have to persist. So finally, later, I read a Ruby book. I am a super Russ Olson fanboy. Russ. I don't know if Russ is out there on the internet. If you haven't read this book or any of Russ Olson's other books, I strongly recommend them. But in terms of design patterns, I think design patterns have kind of come back as being cool in the last year or so. You hear a lot of people talking about them. And usually people will be like, oh yeah, I just implemented the strategy pattern. I'll be like, oh, that's cool. I don't know what the I don't know what really any of these patterns are, and I actually don't care. It wasn't about learning the exact steps, the algorithm of applying some pattern. It's about the idea of building objects and how objects can interact. Building objects of, by, and for other objects to create these complex systems that are made up of simple parts. So that adds in the OO. And I want to tell you basically everything I know about OO. Breaks down to 4 ideas. First one, programs are about collections. If you just had one thing, you wouldn't bother writing a program. You would just do whatever you wanted to do with that piece of data. This page, if your internet could wear out like a book, this page should be worn, it should be tattered. You should have had rebounded, glued it in a couple times. Okay? Handling collections and how you deal with, how you really exercise these methods, I think is the dividing line between a person who writes Ruby and a Rubyist. Ruby does collections better than just about anything else. Oh, sorry, skip that. So I want to give you a little example, a little gem I like about, not gem in the library sense, but a treasure in enumerable that some people skip over. If you had a bunch of holiday M&Ms and you wanted to sort them by color, greens and reds, hopefully you're not all colorblind like I am, so you can actually tell which ones are green and red. In a traditional language, I would write a for loop. I'd walk through the group of them one by one. I'd have 2 arrays, and I would be sticking stuff into arrays. Probably have some conditional branches in there, if this, else that, etc. But that's not really a match for real life. And I think the reason Ruby is great, or can be great, is because Ruby code can match what you would do in real life. In person, I would take 2 bowls. I'd say this is my red bowl, this is my green bowl. I'd go through them one by one, and figure out which bowl they go. Right? Nothing that complex about it. And thanks to enumerable, we can do just that with a great little method named partition. We just send it a block, have that block evaluate to true or false, and then it'll output 2 sets for us, greens and reds. There's no conditions and loops and like for this, int I, that, all this programmer talk. It's just, oh, partition or split up these things based on this condition. Boom, and it's done. A traditional language, I think this operation would take you about maybe 6, 8 lines of code. And in Ruby, we can do it in 1. The interesting part, I'm going to come back to this later, is not the length of it, it's how closely it matches reality, what you would do in real life. So second is just one idea. This, I think, is something Corey was touching on yesterday. I see it kind of come up over and over. In programs, we have layers of abstraction. And at the top level is the application. A correct, in my opinion, a correctly designed application should have just one value proposition. It does one thing. If there's an and, you have 2 applications. And you should break them up. I think 2 years from now, we'll look back at the applications we write right now and go, wow, we wrote some monolithic, crappy applications. Why weren't we working on 6 applications at once that combined to do the thing we were trying to do? So I think that's kind of our area of growth. Second, under application is the module. A module is a collection of ideas, one collection of ideas. Then we trickle down and have a class with just one domain concept, a method with just one purpose, and finally a line with just one thought. I think of it almost like those machines at the grocery store where you like put your change in and it filters down. It's like which level of abstraction does it fit at? So I go from value proposition at the top, collection of ideas, domain concept, purpose, thought. And I want to talk about modules because they're kind of neglected, I think, because you don't need them. You can write a lot of Rails applications, a lot of Ruby applications without modules. And so unless people are kind of forced into it or led into it, a lot of them never try modules. We love organization as programmers. It's probably why we're interested in programming to start out with. I bet if we looked at your backpack, you know, there's like a certain spot for your power adapter, a certain spot for your laptop, your pens, and all that. And modules create those organizational spaces in your code. They could be dedicated, they could be shared. You know, I have one pocket that's just for my power adapter, but I have another pocket that's for like plugs and connectors and those kinds of things. So it could be dedicated, could be shared. So as an example, let's check out this idea of people and businesses. Say I'm building a contact manager, and they want to share phone numbers and email addresses, but then they have some unique characteristics. The person has 2 names, and the business just has 1. This is an opportunity to share code. And if you were kind of, I don't want to say doing it the Rails way exactly, but if you're kind of staying in the Rails mode, maybe, you would do something like this. You'd define a contact class or table, and then you'd store people and businesses in that table, right? So this is STI. The implementation of it would look something like this. And it's pretty neat when you first write it. A couple months down the road, you'll rip it out, and you'll look back at past self and say, past self, it was so stupid. It's a dark and dangerous road, STI. Personally, I have outlawed it. I will never use it again. It can, so we can work together. So the idea, the fundamental idea is good. The implementation is not as good. Instead, we could do reuse via module. We don't have to skip, we're going to skip inheritance, but still get the idea behind inheritance is having multiple things that share the same code. And you can do that with modules. The Ruby object model is very flexible. And using modules, we can reuse code, make things composable, have them used in multiple places. We can virtually inherit from multiple source classes, being modules. I always use code before I write it. So I would write something like this, where I would include the module. That's what I would like to write. Now, surely in Ruby, there's always a way to make it work, right? So if I write this, then how do I write the module to match? And it goes like that. It could go in your models folder, it could go in a different folder. The included callback trips people up. The way included works on a module is it gets as a parameter the source. A lot of people write base, but to kind of help Aaron Patterson's cause, I'm trying to not use base. Say source. Okay. The source that gets passed in, and then on that source, I want to trigger some private methods. So I send the message has many and tell it to pass in the parameter phone numbers and pass in the parameter email addresses. The send triggers the private method. So that's one way that I use modules frequently in my models. The second one, and this is, again, linking back to what Corey was showing yesterday, is what I call utility objects. And this is a use that I think, I don't know why it doesn't seem to occur to a lot of people. It's really easy to do. Imagine a blog like this. You want to filter both the article body and the comment body. So obviously, there's repeated code here. It's going to get a terrible metric foo score. One temptation would be to monkey patch string. Let's add a sanitized text method to string, and then we can just call it in both places. But I think monkey patching is almost never the answer. It's always my answer of last resort. Instead, we could implement a text decorator module like this and include it. And then you would have that instance method in the model. But, and again, Corey touched on this just briefly yesterday, I don't like this because, to me, an article is not made up of a text decorator. When I say include text decorator, that means that what I'm communicating, in my view, is that this class is in some part made up of this other thing. And an article is not made up of a text decorator. An article is made up of a body, a title, an author, those kinds of things. So instead, I'd use this other approach. Define a class method in the module here, and then call it from both those places. It's really simple. It's, the functionality is the same, but the concept is different. As opposed to saying that an article is made up of a text decorator or a comment is made up of a text decorator, I'm saying now it uses those things. Those are utilities utilized by this class. And what it comes down to is this idea of clear over clever. And this is something I've been trying to really emphasize in my development lately. Ruby is powerful, maybe intoxicatingly powerful. We do have those Perl roots, so there are always 6 ways to do anything. But you have to ask the question, or think about the future. What would future me think about this? Is future me going to pat himself on the back and say like, oh, that was really cute? No. More likely, future me is going to look back and be like, asshole. A, you wasted half a day optimizing these 4 lines into 1 line. And number 2, I don't remember what it was doing in the first place. Instead, we should always seek clarity. So refactoring, I like to say refactoring is my favorite sport. Refactoring and code golfing are very different. And I think refactoring can sometimes get a bad rap because people kind of conflate them together. Refactoring is not about turning code like this into this. Brevity is often a side effect of refactoring, but it's not the goal. The goal is to bring the code close to the concept. How can what we write on the page translate more clearly to the world we live in? The real goal of refactoring, in my opinion, is to not go from here to here. It's to make the implementation completely fade away. That the implementation is just saying the same words I would say to you if I were explaining the process. That's when refactoring succeeds. So one whipping post I like to beat on is scopes, and kind of a good example here of clarity versus brevity. So in Rails 2, we got scopes named scopes, and they were awesome. Why were they awesome? Well, they're expressive, okay? And in the usage, what was really critical about this? Yeah, composability, right? And then in Rails 3, A-Rails stole the magic. A-Rails simplified the syntax of writing scopes. We didn't have to write named anymore, but importantly on the A-Rail part, we could say where and limit and all those things. And stole the magic from scopes. Now we could just write normal class methods, get the same composability, and have no artificial lines between things that are scopes and things that are class methods. And I would recommend to you that you not write scopes anymore. I think scopes were kind of an artificial stepping stone in between. Writing refactoring to class methods is significantly longer. I've taken 2 lines of code and turned them into 6. But it's so clear, especially from the outside of the class. Outside the class, when you're talking to interface, you don't care whether it's a scope or a class method or what have you. You just want to trigger your action. It becomes a little more clear, I think, when you add parameters. And this is something that used to trip me up. And I was like, lambda, wait, where does the bracket go? And all that. I did like what Jose was saying yesterday about having lambdas instead of blocks. But in this context, whenever I hit the lambda, I was always like, really? Do we have to have a lambda just to pass in a parameter? And explaining this to people who are new to Rails, forget about it. It's like, oh, just trust me, just write this. It's basically, you know how you used to trust me to write, like, how's it go? Public static void main? Just write this. It's like that. Wait. Oh, no, I think I clicked the wrong button. Sorry. Instead, with the class method, you can just put in a parameter. Put in max. There's nothing fancy about it. It's just a method. And at that's the point where, to me, you cannot argue that this is significant. Well, you cannot disagree that this is significantly clearer than what's happening here, the structure of what's happening there. The simplicity eclipses brevity. So the second one, kind of similar vein, is active support concern. This was introduced, if you're not familiar with it, in Rails 3 to kind of simplify how modules were written. And so if I had a normal module like this, this uses the same pattern I did before of calling included, having some has-manys, and I cause the source class to include the instance methods nested module here. Okay. This is a very common pattern when you write modules, and active support concern tries to simplify or shorten it. With active support concern, it would look like this. You would extend active support concern. You would then have access to an included method, as opposed to having, back here I had def self included. Now you have included method that you call, you pass it a block, and these things are the same. But the third there has been eliminated. The source send include instance methods, that's done for you. If you have a nested module named instance methods, those are added with include. If you have a nested module named class methods, those are extended onto the calling class. But I don't think this is more clear. It's more magical, yes. It saves a little bit of code, yes. But it's not clear. To me, I think people like it because they don't want to understand what is happening here. Source send, calling methods, what? You know, I told this some people on Tuesday, oh, I never knew what send did. It's important. It's important. You know, we shouldn't just like gloss over these ideas because they look fun. It's actually very critical. So we send a message, call include, give it the parameter. So I prefer this implementation, and I don't use active support concern, and I'd recommend you don't either. Clarity, simplicity, not brevity. Good rooting allows the ideas to shine through the implementation. Your job as a Ruby programmer is to communicate, not to write programs. You're communicating with the machine, translating what you understand about the world into the instructions that it can comprehend. If you follow these rules, future you will thank you. And that's it.